What is dynamic programming?
Dynamic programming is a powerful coding technique used to solve problems by breaking them into smaller, overlapping subproblems. It efficiently stores and reuses solutions to these subproblems, making it ideal for complex tasks where simple recursion would be too slow or memory-intensive. Dynamic programming is widely applied in computer science, finance, data science, and many real-world scenarios.
1. The shortest path problem, optimizing routes.
Finding the shortest route between locations, such as in navigation apps or flight booking systems, is a classic problem solved by dynamic programming. Algorithms like Dijkstra's or the Bellman-Ford algorithm use dynamic programming to efficiently determine the least costly path in a network of routes, accounting for changing distances, roadblocks, or travel costs.
2. Knapsack problem, making the best choices.
Imagine needing to pack a bag with limited capacity for a hiking trip, choosing items to maximize total value. The knapsack problem captures this scenario. Dynamic programming is used to systematically determine the optimal combination of items to pack, balancing weight against value and ensuring the best results in resource allocation, shopping, or logistics.
3. Sequence alignment, DNA and text comparison.
Comparing DNA sequences in genetics or measuring the similarity of words in spell checkers involves aligning two sequences to find their best match. Algorithms like longest common subsequence or the Smith-Waterman algorithm rely on dynamic programming to efficiently compare sequences and identify regions of similarity or difference, crucial for research, biology, and language processing.
Why these problems matter?
Dynamic programming makes it possible to solve essential real-world challenges, from finding the fastest routes, making the best choices with limited resources, to understanding patterns in data. Mastering these techniques enables efficient solutions in diverse domains, from everyday apps to scientific research and complex decision-making.